We said that current is the flow of charge in a specific position over time, and it's equal to Q over T, where Q is the charge in coulombs and T is time. The unit for current is amperes, and the unit for charge is coulomb, unit for time is seconds. Then we talked about resistance, which is a device of resistance in general. It limits or resists the flow of current in a circuit. So the following is the equation for the resistance. Resistance is equal to the following. It's equal to resistivity, which is a property that depends on the type of material and how it's able to resist flow of current, multiplied by the length of the material divided by the area. And resistance has the following equations, unit. So resistance has the unit of ohms, resistivity has the unit of ohm meter, length has the unit of meters, and area has the unit of meters squared. Now, depends on the type of area or the type of cross-sectional area you see, you develop some equations. So let's say that you have a circle, which is most of the wires are cylindrical. So when you cut it, you will see a circle. So we have a radius, which means that the area here is equal to pi r squared. Or you can write it as the following: pi d squared over 4 if you are given the diameter. If you have a square, so square's area is easy, it's equal to side squared. If you have rectangle, it's length times width, and so on. Then we can relate current to resistance in the following equation, which is known as Ohm's law. So Ohm's law says the following. It says that voltage is equal to resistance times current. So let's do one of the examples in the worksheet. Or let me do one example before, and then we do the example in the worksheet. So let's say that we said the following. So a 5 ohm resistor is connected to a 10-volt battery. Find the current passing through the resistor Let's do this as part A. Part B, find charge that passes in 60 seconds. Or let's make it like this, that passes in 3 minutes. And part C, find number of electrons that pass. So first thing, we want to find the current passing through the resistor. We are given the resistance value or the value of the resistor, and we are giving the voltage value. So we'll say that current is equal to voltage over resistance, which is equal to the following: 10 volts over 5, which is equal to 2 amperes. Then we want to find the charge that passes in 3 minutes. So we know that current is equal to charge over time, and if we rearrange it, we get that charge is equal to current multiplied by time. However, time here is given in minutes. We need to change it to seconds. So we'll have 2 amperes multiplied by 3 minutes, and the 3 minutes, to change it to seconds, you need to multiply it by 60. So 3 times 60, which is 180, multiplied by 2, which is 360 coulombs. Find number of electrons that pass. We know that charge is equal to number of electrons times the charge of 1 electron. So we can say that the number of electrons is equal to charge over charge of 1 electron. So we have here 360 coulombs divided by 1.6 times 10 power minus 19 coulombs. Coulombs will cancel coulombs, you'll get a number, and that would be the number of electrons passing. Let's do some examples from the worksheet. Okay, I'll do questions 16 and 17. Okay, question 16 is saying the following. It's saying that a wire with an initial length L initial and radius of R initial has a measured value of resistance of 4 ohms. The wire is drawn under tensile stress to a new uniform radius where the new radius is equal to 0.5 times old radius. What is the new resistance of the wire? So we have R old or R initial is equal to rho times length initial over. Since they mentioned radius, we should know that it's the area of a circle, so it's a cylindrical wire. So pi times R initial squared. And they gave us that R initial is equal to 4 ohms. Then they told us that the following has happened. So the radius became a new uniform radius, so we can say that R in U is equal to 0.5 R old, or I can write it directly as R old over 2. Then we can do the following. Since we have tensile stress, it means that the same volume of the material will exist. However, what is the volume equation for this? So if we have a wire, the wire is a cylinder. So here we have radius, here we have length of the cylinder. Volume of the cylinder is usually given by this equation. It is pi times R squared times L. So as you notice, it is the base area multiplied by length. So we'll do the following. Since we have tensile stress, it means that volume old should equal to volume new, because it's the same material, we didn't add anything else. Volume old was equal to the following. It is pi times R old squared times length old or length initial R initial, and it is equal to pi times R in U squared, and we know that R in U is equal to R old over 2. So we'll write it like this: R old over 2 squared multiplied by the new length, which we need to find. So we need to find the new length so we can plug it into this equation. So now we do the following. We say that pi R initial squared length initial is equal to pi. We have here R initial squared over 2, so it will be R initial squared over 2 squared, and 2 squared, which is 4, times length initial. So what is length final? What is cancelled? Pi is cancelled with pi, R initial is cancelled with R initial, and we have that length old is equal to length new over 4, which means that the new length will be equal, we cross multiply, to 4 times length old. Now since we got this, now we can plug it into the normal resistance equation, where it says the following. Resistance in U will be equal to resistivity. Since it's the same material, it means that they have the same resistivity, times length in U over pi times R nu squared, which is equal to resistivity times 4 length old, because this is equal to this, divided by pi times. Now we remove R nu squared and we replace it by R old over 2, which is given in the question, and we square it, which will be equal to the following: 4 resistivity times length old over pi R old squared over 2 squared, with 2 squared is 4. So if we have this form, now this will be up and multiplied by this. So we'll have 4 times 4 multiplied by resistivity times length over pi times R initial squared, and all of this length old, R old, and so on was actually the 4 ohms. So we'll have 4 times 4 times the 4 ohms, so which is 16 times 4, which is equal to 64 ohms. This is the new resistance. So this is R new. So this question is saying the following: suppose that you wish to fabricate a uniform wire out of 1 gram of copper. So they give us that the mass of the copper that we have existing is 1 gram, And we know that the SI unit for mass is kilograms. So to change from grams to kilograms, you do the following. Either you divide by 1000 or you multiply by 10 power minus 3, which is basically the same thing. So we'll have 1 times 10 power minus 3 kilograms. And they told you that suppose that you want to have a resistance of 0.5 ohms. So we know that resistance is 0.5 ohms, and they are saying all of the copper is used and we're using the full mass. And they told you that the mass density of copper is 8,920 kilograms per meters cubed. So we have the density and it's given as 8,920 kilograms per meter cubed. And we have resistivity and it's given as 1.7 times 10 power minus 8 ohm meters. They are saying find the length of the wire and find the diameter of the wire. So first thing, based on those givens, we need to do two things. Since we have the density and we have the mass, we can get the volume, since density is equal to the following. It is equal to mass over volume. And why are we trying to get the volume? We are trying to get the volume because we know that the volume is equal to the area times length. So first thing, let's get the volume. So here, volume, we cross multiply it with density, which means that it would be in density's place is equal to mass over density. Which is 1 times 10 power minus 3 divided by 8,920, which is equal to 1.12 times 10 power minus 7 meters cubed. So after getting the volume, we can do the following. We can say that 1.12 times 10 power minus 7 is equal to area times length. So from this equation, we can do one thing. We can write either area in terms of length, or we can write length in terms of area. So let's keep it here for a while and check what we want to eliminate first. We know that resistance is equal to the following. It's equal to resistivity times length over area. And we know that we have a value of resistance, we have a value of resistivity, and we need to find length or area. So here we have two equations with two unknowns. So it's easier always to find the length first, because when you want to find the radius, you need to plug in pi times r squared and then you do square root, which is you can do from this one easier. So let's write length, or let's write area in terms of length. So we remove the area and put it in terms of this equation. So from this equation we'll get that the area is equal to 1.12 times 10 power minus 7 divided by the length. So now let's plug in. We are given that the resistance is 0.5. So we have 0.5 is equal to resistivity, which is given as 1.7 times 10 power minus 8 multiplied by the length divided by 1.12 times 10 power minus 7 over length. And again, we have length here and length up. So we take this length and we multiply it by this one. So we'll get the following. We will get that 0.5 is equal to 1.7 times 10 power minus 8 times length squared, and it is divided by 1.12 times 10 power minus 7 times, okay, that's it. Then what do? We do cross multiplication, which means that we will have 0.5 multiplied by this, and 1.7 times 10 power minus 8 will be multiplied by 1. So 0.5 times 1.12 times 10 power minus 7, which is equal to let me calculate it please يا يحيى. 0.56 خلاص 56 times 10 power minus 7, and it is equal to 1.7 times 10 power minus 8 length squared. Then in order to find the length, 3.29 ايش هو 3.29 في Okay, so after that we need to divide both sides by whatever is multiplied by the length, which is the 1.7 times 10 power minus 8. So this is cancelled with this, and we have 1.7 times 10 power minus 8, which is equal to, when you divide this by this, you get 3.29 is equal to length squared. Now this is length squared. Length will be equal to square root of 3.29, which is equal to the following: 1.81 meters. Now you found the length. How would you find the radius? You have two options. Either you take this and you plug instead of area pi r squared, or you go back to this and you plug the length here and you find it from the area. So let's do it from the first one, from the second one, because it's easier. So we'll do like this. So 1.12 times 10 power minus 7 is equal to pi r squared times the length, and our length, which is 1.81. So basically we're using this formula. So we'll get that r squared is equal to the following. We divide by everything which is multiplied by r squared, which is pi and 1.81 for both sides. So we divide by pi multiplied by 1.81. And we will get that r squared is equal to times 10 power minus 7 divided by 1.81 pi. It's equal to 1.97 times 10 power minus 8, and we need to do now square root. So r is equal to square root of this value, which is 1.97 times 10 power minus 8. So we'll get that the radius is equal to 1.4 times 10 power minus 4 meters. This is the radius, and if you want to get the diameter, you know that the diameter is 2 times the radius, which will be 2.8 times 10 power minus 8 meters. So this question 15, is saying the following. So when connected to a 5-volt battery, so you are given voltage of 5 volts. A current of 2 amperes passes, so we have 2 amperes current through a copper conductor that has a length of 100 meters, so we have a length of 100 meters, resistivity of 1.72 times 10 power minus 8 ohm meters, and we are saying calculate the radius of the conductor. So we have length, we have resistivity, and we want the radius, so we need to use this formula, which is resistance is equal to resistivity times length over pi r squared. However, here we don't know what's the resistance and we don't know what is the radius. We know the resistivity and we know the length. So from where do we get the resistance? We do the following. We know that V is equal to R times I, which means that R will be equal to voltage over current. And voltage is given as 5 and current is given as 2. So we'll have the resistance as 2.5 ohms. Then we will say now, okay, we have the resistance. We just plug into this. We say that 2.5 is equal to resistivity, which is 1.72 times 10 power minus 8 multiplied by the length, which is given as 100 meters, divided by pi times r squared. So we only have one unknown, which is r squared. So we do the following. We do cross multiplication as usual. So we will get the following. We will get that 2.5 times pi times r squared is equal to 1.72 multiplied by 100, 1.72 times 10 power minus 8, and all of it is multiplied by 100. So in order to get r squared, we divide everything which is multiplied by r squared. So we have 2.5 multiplied by pi. We do it for both sides. This is cancelled with this, and r squared will be equal to the following. So 1.72 times 10 power minus 8 multiplied by 100 divided by 2.5 pi. So radius squared is equal to 2.19 times 10 power minus 7, which means that the radius is equal to square root of that value. So 2.19 times 10 power minus 7, and it will be equal to 4.6 times 4.67. We can round it to 4.7. So 4.7 times 10 power minus 4 meters.